if I really have an unstructured data problem, it's better to use an unstructured data environment and unstructured data tools, and likely significantly cheaper too.
So we want to talk about radical DBMS alternatives here, and this was some of the things, because it's more than an impressive title. I think there really are some impressive things happening out there. A couple of things that I picked up from reading through some of the things that Gartner's been putting out. One is the processing moving to the hardware layer. I mean, that seems like a radical alternative to me, or maybe something that we all need to be aware of. What is that?
Well, it can mean a couple of different things. You know, a lot of folks are talking about in-memory databases. Obviously, one of the bottlenecks in database systems has always been what we call I/O, input-output, moving the bits on spinning metal things and back off again. And associated with that activity, we create buffers. We manage the most recent use of that buffer. We flush the buffer when it's full and put new data in it. A sizable percentage, some people think the majority of some DBMS code lines, is all about that process. Well, or process. If I decide that all of this is going to happen in memory and I architect my system to use memory only, well, I build a very different computer. It has much more memory and much less storage. And I have a completely different set of code that conforms to that. So that's one way of thinking about using the hardware differently. Another way is I am going to use storage. But storage is a lot smarter than it used to be. The boxes it comes in have processors of their own. I can push a lot of the work down there to the storage layer and do a lot of pre-calculation, pre-filtering, pre-sorting, pre-aggregation, and only bring a smaller result set up to the memory that's attached to the processor, and therefore get a great deal more efficiency. Fundamentally, that's what something like Oracle Exadata does. Other systems are attempting to do the same thing. Some are building on more memory. And then at the really low level, if I think about what happens on the chip itself, there are things I can do that expedite some functions that could otherwise dramatically slow my performance. The most obvious example there is encryption. I can encrypt and decrypt on the chip and not have to use the software layer above that to process that, which would slow down everything else. Intel put those instructions into Xeon some time ago. Very few software stacks have actually been recompiled to take advantage of that capability because encryption hasn't been a priority for a lot of people. But the biggest gap in most big data architectures is security. And Intel is now in that Hadoop game themselves, selling a distribution that actually moves that into the hardware. So there are a variety of different ways I might exploit the hardware to improve processing speed, and that's always the goal. It's how can I scale faster, more effectively, securely, at least cost. And I want to make use of every asset I have. So if I've bought storage devices that happen to have compute capability, why not partition the workload so some of the work gets done down there? I can get a lot more bang for my buck that way.
Sounds like, I mean, we've gone from flat files to relational systems, and it sounds like we're in danger of leaving a lot on the table if we don't understand this new hardware layer.
And the new software layer, but yes, absolutely. The opportunities of less expensive memory, of 64-bit operating systems, of high bandwidth interconnect and parallelized data architectures and parallelized processing systems, most of those recent innovations post-date the design of most of our software. And most of our software is not designed to exploit those things. And so we have unmet opportunities here that we can exploit to our advantage if we learn a little bit more about what's going on.
And for the CIO, what does that mean for his shop? Or her shop? And what should we be doing?
Surveying the landscape, talking to your friendly IT research provider, keeping up with the changes. Your vendors will be happy to educate you. Of course, bring a salt shaker with you. But many, many things have changed, and distinguishing the truly valuable innovations from the less valuable ones is probably a good idea.
Okay. There's one more thing that really struck me in terms of these radical alternatives, and for me it is anyway, and that is this no SQL DBS. What does this mean?
What it means is that not every processing algorithm needs to conform to the relational model. Many of the use cases don't have anything to do with rows and columns as we understand them. The value of the RDBMS when it evolved from the prior systems was that it became a place where certain structural expectations were met, design centers were formed, and in many cases the enforcement of policy was centralized. So, obvious example, one of the first things people learn when they learn this is about referential integrity. If I have a customer and an order, I'm in good shape. If I have an order that doesn't have a customer associated with it, there's something wrong. And the machine, the software machine, checks that for me, ensures that I don't build things that don't conform to my rules. Prior to that, back when I started writing programs, all that logic existed in every single program I wrote which operated against that file. So we got an opportunity to centralize policy. Well, as it turns out, the current style of programming doesn't always think that way, and many things are built where the program and the logic and the storage are very tightly coupled, and whether that turns out to be a good idea architecturally in the long run or not, that is the way we're doing certain kinds of processing. So people who write JavaScript object notation want a simple file store that hold the data as it is defined in the program. That's what document-style NoSQL databases do. People who write embedded systems that need to be very, very lean and totally no maintenance because everything happens in the program might want to use a key value store. That's another kind of NoSQL database, and that's a very popular type. Some look a lot like tables, but don't enforce the same rules as pure relational databases do, and because they don't, they can potentially scale a lot more easily, and they can potentially be a lot more easy to use for the relatively smaller set of tasks that they're used for, and certain assumptions about synchronization, like the famous two-phase commit in a transactional environment that says I can't proceed until I know absolutely that this has happened at the other end, may not be necessary. Well, we have not typically had databases that would allow us to relax those assumptions and get the benefit that relaxing those assumptions allow us to get, which is simplicity, speed, scalability. And for many situations, it turns out those are excellent alternatives, and people are beginning to partition their portfolio of applications to identify which ones are better served by these simpler and probably less expensive alternatives.
So is this the secret to managing unstructured data?
Sometimes.
Yeah.
Typically, the idea that I take unstructured data and somehow shred it or manipulate it or tag it in order to pour it into a structured container is at best less than useful, and at worst utterly misguided. So if I really have an unstructured data problem, it's better to use an unstructured data environment and unstructured data tools, and likely significantly cheaper too.
This has been our discussion with Merv Adrian, the Research VP with Gartner Group. Some fascinating discussions on DBMS, databases, and data management.